All right, so now they're asking the same sort of question, but with period, right? Okay, so the resonant period is 4 seconds, right? Which means, by the way, our resonant frequency is what, 0.25 or something like that hertz. Okay, so let's see, what is its relative amplitude and phase relative to the driver when it's being driven by a period of 0.5 seconds? Well, gee, that means that this driver is faster than the oscillator, right? Okay, so relative to the oscillator, right? The driver. So this is the oscillator is a slow system, right? So this guy is going to lag. The oscillator is slower than the driver, right? So it's going to lag 180 degrees. Whoops, and it's also going to be a small amplitude. Okay. And then we drive it with a period of 20 seconds, right? Well, now relative to the driver, the oscillator is a fast oscillator, right? Okay, so it's going to be in phase. But since 20 seconds is not the same period, right, it's going to also be a small amplitude. Okay. But now we're driving it at its resonant frequency or period or whatever, right? Okay, so this is going to be a big amplitude. Okay. And because it's resonant, it's going to be 90 degrees behind the driver. Okay. So again, as far as amplitude goes, you're just looking for something that matches. If it matches the same frequency or period, it's going to be a big amplitude. Otherwise, it's going to be a small amplitude. Okay. If it's much farther, if it's pretty far from the resonant frequency or period. Okay. And then if it's that the oscillator is faster than the driver, it's going to be in phase. So fast oscillators stay in phase, slow oscillators lag 180 degrees, and resonant oscillators are 90 degrees. Okay.